Inverse functions. A function f has an inverse if and only if it is 1 to 1. This function is 1 to 1. Given y, we can find the x value where f of x equals y. So this function has an inverse. This function is not 1 to 1. Given a y value, there are two possible x values where it could have come from. So this function does not have an inverse. A quadratic is not normally 1 to 1, but if you restrict the domain to x being greater than or equal to 0, then it is 1 to 1. So let's find its inverse. Change to xy notation to do this. Then have x and y change places. Solve for y, and then choose which function is f inverse. To do that, I like to make myself a sketch. The domain of f is x being greater than or equal to 0. And so f inverse must take on the values greater than or equal to 0. And so f inverse is the positive radical x minus 1. Notice that the function and its inverse are symmetric about the line y equals x. This will always be true about a function and its inverse. The function, or this function, is 1 to 1. Let's find its inverse. Change to xy notation, and then have x and y change places. Looks like I have a little typo on this page. You'll continue to see that typo. But what we need to do is we need to solve for y. To solve for y, first multiply both sides by y minus 1. Distribute the x. Get everything with y to the left-hand side and everything else to the right. Factor out your y, and then solve for y by dividing both sides by x minus 2. Once you have solved for y, you choose which function is f inverse. Now, in this case, there's really no choice. But we do want to point out that x cannot take on the value 2. All right, let's do something a little bit different. The slope of the line tangent to f inverse at y naught x naught is the reciprocal to the slope of the line tangent to f at x naught y naught. So two things I want you to notice. Notice the change of the ordered pair. Also, notice how it's the reciprocal. I'm going to help you sort these details out. This function is 1 to 1 for x being greater than or equal to 0 and has an inverse. Find the slope of the curve of f inverse at 3, 1. We would prefer to do this without finding the inverse function. What does this mean? This means that f inverse evaluated at 3 equals 1. If f inverse evaluated at 3 equals 1, then f of 1 equals 3. So the point 3, 1 on f inverse corresponds to the point 1, 3 on f. So that's why the ordered pair switches like that. It's going to be most helpful if we look at a graph. The point 3, 1 on f inverse corresponds to the point 1, 3 on f. To find the slope at 3, 1 for f inverse, we're going to have to find the reciprocal of the slope of f at 1, 3. Find the slope of f at 1, 3. To do that, first find the derivative of f. After you find the derivative of f, evaluate it for x equals 1. Evaluating it for x equals 1, we get the derivative of f evaluated at 1 equals 5 halves. So the slope of f at 1, 3 is 5 halves. The reciprocal of 5 halves is the slope of f inverse at 3, 1. So the slope of f inverse at 3, 1 is 2/5. I recommend making a sketch of the graph of f and f inverse and using this method. It's a little bit easier than using the formula. At least it is for me. Now you might be saying to yourself, well, how am I going to graph f? I mean, and f inverse. I mean, I don't even know what f is. So what I do is I just make up. I just make up a graph f inverse and just make sure it goes through my given point. And then I make up my graph f, making sure it goes through the corresponding ordered pair. So I just make a little pretend graph. And then that helps keep me straight. And then I tell myself, to find the slope at 3, 1, I find the reciprocal of the slope at 1, 3. And that makes it a little bit easier for me to figure out. All right, so take care. And I think I said earlier that I don't even know what f is, and of course that was an error. So anyway, I think you mostly followed what I said. Take care, have a great day.